Well, hi, good morning, and thanks so much for joining me here in my shop for day 2 with this surprising radio. Today is actually June 19th. So, yesterday my experience with this radio was great. Turns out it's working. It's working actually quite well. It's almost working so well that I'm anxious about making any changes to it for fear of simply degrading its operation. That's how good it seems to be working. FM not so good, but the AM side very good. So I did mention something about European radios being more complicated than their similar American counterparts, or North American counterparts I should say. So maybe the next thing for me to do with this is to get more familiar with the radio circuitry by going through the schematic. So that's what I think I'm going to spend some time doing. I managed to download it from Radio Museum. I'm a member of Radio Museum. Great source for all kinds of stuff about radios and that. Not just European ones either. But so we're going to switch over to the schematic, and I'm just going to wing it. I haven't studied it. I'm looking at it basically for the first time, just like you. Okay, here we go. Now this is half the schematic. This is one page. There's another page over here. But, German here, English here, and more. Oh, French over here. Very interesting. Okay, what does it say? Schematic diagram with current and voltage data. Great. Adjust the trimmer condensers. The adjustment of the trimmer condensers should not be varied, since otherwise the conditions as to the oscillator radiation stability and alignment are no longer guaranteed. Okay, now they put this note right front and center at the top of the schematic. So this is a big warning here. Let me just read it again. The adjustment of the trimmer condensers C606, 607, 613 should not be varied, since otherwise the conditions as to the oscillator radiation, stability, and alignment are no longer guaranteed. They're guaranteed if you don't touch those 3 capacitors. The condition as to the oscillator radiation, stability, and alignment is guaranteed. Okay, well, I can't extract any more out of that. Well, I'm just going to have to be conscious when I get around to the point of trying to twiddle things to pay attention to this. Okay, maybe we'll encounter these as we go along through the schematic. Are there any other scary notes? There's one in German. Voltages are measured with a 50,000 ohm per volt. Measurements done in the FM position. Shows the terminals of the VHF input and mixer unit. VHF input and mixer unit. Okay, not exactly sure what that is. Maybe it's reference to a stereo, but I think we've used the word stereo there, so I don't know. Sometimes these radios have a separate stereo demodulator you can get. What do we got generally in the schematic? We've got, excuse me, plug in the wall, transformer, half of it on the other page, 2's identity. Oh, look at this, I got the North American equivalent. ECEF 89. Really? A 6BA6 is the same as an EF 89? Huh. EABC 80. You know, the more letters the tube has, the more functions the tube has. 68, EL95. So EL95, 6DL5. Uh-oh. Well, the tubes are good in this radio. I certainly hope this one's good because I don't recognize it. And EM84, that's the Magic Eye tube, which we saw was very bright. So here's the layout of the switches. Isn't that helpful? Holy smokes. Just to make it even more helpful, how are these laid out? They must be looking at them from underneath, because this off is actually on the left side and the FM's on the right side when you look at the radio. So again, this must be viewed from underneath. Okay, let's go to the schematic. Here's our antennas here. These must be different arrangements for different bands, depending upon which band you're on. Here's AM band, shortwave 2, shortwave 1. And then is there a button that says FM? Not really. You can see the double switches here. So between this line, or this line and this line, you're selecting this entire circuit, or this one. It's this ground symbol. What does this mean? Does this mean chassis? We'll find out. Probably does. It's all over the place. I didn't see any other symbols. Wow, it's everywhere. That's an interesting thing right there. This indicates slug tuning. This is in a box here. This is the FM tuner inside here. That's the FM tuner 2. If you like, an output comes here. This is probably 10.7. I'm not exactly sure, but I think it is 10.7 already coming out of here. So the higher frequency stuff, you know, the straight 100 megahertz FM signal, and that is all contained in this box, where they can take good care of it. The lower frequency, 10.7 being a lower frequency, then is produced into the rest of the radio, which doesn't have to be as critically designed for a 100 megahertz signal. So don't fool in the metal box. Now, signal coming out of here. Now what's going on down here? So the AM signals from the 3 different AM bands brought up here. Yeah, so they've ganged these 2 slugs inside the FM tuner, and they've ganged these 2 sets of plates on the AM tuner. Just two sets of plates. Is that all you got? Okay, I'm looking at the radio here. 2 sets of plates. There they are. So this set is reacting against this arrangement here to produce some kind of resonant peak. It's going into this mixer tube, which also has a, looks like it has a triode. Hey, there's no cathode on the triode here. What's going on there? Didn't bother drawing it in. There's the cathode there. They just didn't bother drawing it over here, I guess. So going through this tube, then it could be that this also mixes the, what am I trying to say here? Let's look at the oscillator. So here's the oscillator. See, there's 3 sets of coils. So this is for the AM side, the FM side. What's this FM switch here? FMC. I think all the oscillator and mixing takes place in here. I think. So the AM side is producing a local oscillator frequency with these 3 setups. Where are they hooked up? So let's see. So signal coming in on grid number 1. In this case, they put the signal on grid 1. Often in these radios they put the local oscillator on grid 1, but not in this one. Not in these radios, just in radios. So on grid 3 is the local oscillator. This looks like it's grounding everything out. It's killing the grid 3. So you put it on FM, it kills whatever's going on in here. It will be killed by this. Okay, now assumably, what is happening here? Don't exactly know what's happening here. This grid. Oh, this is the oscillator amplifier, of course. That's what this is. So to make these aren't going to oscillate on their own. They need an amplifier in there. There it is. Okay, so that's the AM amplifier for the oscillator, and then the oscillation, which is going along here, is on this line, which is the grid. There we are. Okay. kind of got that figured out. You know, there's a rule I learned a long time in life, and that is investigations. If you think of what I'm doing right here as an investigation, investigations proceed not until the truth is known, but until the investigator is satisfied. Now, hopefully, the investigator is satisfied because the truth has appeared in front of him, but that's not always the case. The investigation, when it ends when the investigator is satisfied. That's all. Now, let's go look at the next page. I'm feeling pretty satisfied, that's why I wanted to say that. Any English here? No. Oh, that looks like Spanish. Wow, okay. This radio is all over the world. That's what this means. This radio was sold by the thousands, tens of thousands. Well, yeah, hopefully you would do a really good radio design before you try to manufacture and sell tens of thousands of them all over the world. Okay, so we have the output, the mixed output coming here, and it's feeding through both IF cans, the FM and the AM. Which is which? I'm not sure here. Can I tell? FM. I think the radio, they said something about FM. It's showing, I think they said on the other page the schematic was with the FM switched on. So this conceivably means FM is on. That would mean this is the FM. 10 220. I don't know. What's this? Little filter right inside here. Okay. So assuming this is the FM one, then the 10.7 will go through this transformer, come out, and 455, assuming it's 455, I haven't seen it yet, going through this one, or vice versa. One way or another, stuck on the grid. You have one voltage here. Often, as you switch between AM and FM, the voltages change in the radio. Let's go back to the other schematic for a sec. I thought I saw more than one, but this is what I saw. Two different lines. Yeah, okay. So it looks like the voltage is the voltage here. Or is this all FM? Maybe there's a table somewhere that shows these voltages. Let's carry on. 45 volts. What is this line? So you see this great big resistor here, 1.5 megohm resistor. Chances are this is the AVC line. Looks like I can get all the way to the grid. There's a little DC there, so maybe if we just sneak back this way a little bit. We look up here at the detector tube, we can spot the detected. Oh my gosh, look at this monster here. This has got to be the FM detector arrangement in through here. This would be the AM one here. Comes up, single plate, nothing complicated. So this is the AM audio coming out down here. 220K, 100K, then we're on this line. Get past this big resistor where the high impedance part of the circuit can feed grids safely. Let's do this rather complicated looking switch here, doing stuff. Volume control, okay, no doubting what this is. So you can see the audio coming down. Where did it come from? Coming from here, getting through the switch here onto this spot, I think. Getting on the top of the volume control here. Ooh, what's this? Tone control. So the tone control is just sinking some of the treble off this line here. And this line's going back up to the triode amplifier that's built into this tube, unnecessarily, but to make the tube sell better. Stuck a second function inside the tube, which is always needed in these radios. So smart are the tube makers. So down here, the amplified audio. Let's go back here for a minute. Tone. What's all this stuff? This is probably feedback. Probably a feedback scheme. I wouldn't want to bet on that. I don't know. This looks like filtering of some sort. Okay, so audio coming out here, as I said before, a shielded wire because very low signal level. In and around. This very important capacitor here. Out to the output tube, single output tube. Bypass on the cathode resistor, giving us the bias voltage here. So plate voltage on the output tube is 250. That should be the highest voltage in the set, other than on the actual filter capacitors down here. Might be a little higher, 212. We'll look at the power supply in a sec. So output here, going through the output transformer. One side of the speaker is tied to the chassis. Well, kind of monkey business going on here. And what exactly is this? This must be the feedback. This must be a feedback scheme. Almost like it's pumped into the bottom of the volume control. So I don't understand the circuitry, but this is the area where the design engineers and fooling around with tone control and feedback and things like that, this is where they really go to town. So often I find in these radios, in this area, the circuitry is a real head scratcher at times with things like this done. So I think that's what's going on. The design engineers scratch their heads really hard, and this is what came out of it. And they don't want their radio to look like the other guy's radio. They want their radio to have some special stuff in it. A piece of their mind. They want a piece of their mind in this radio. Okay, enough of that. Power supply. Where's the power supply? So here's the power supply transformer, which we saw on the other page. It's a solid state rectifier. This, I need to look at this and make a decision whether it's good to go. Probably is, or maybe I need to replace this. This is probably selenium, but I don't know. Often these radios, these guys are little metal cans, and they, not even hot. So you got 50 millifarad. I don't remember the radio humming. Look at the tube arrangement here. So we have a light, 7-volt light. Look at 300 milliamps. So the light that's in there's no way that's a 300 milliamp light. I think that's an incorrect replacement. So 300 milliamps, that's roughly what a tube draws. And we have the tubes, nothing too special going on. A capacitor here. Oh, what's this? TU1. Well, what's that? What is a C6? Hey, C609. Is that one of those? Is that one of those guys? Oh my! What is this? So this kind of symbol, sometimes it means the wire is passing through a can, and the can has a capacitance, and this is how that pass-through has a capacitance. Now usually that kind of stuff is happening up here, like that. There's one. And there's something like that there, but they show a resistor on the other side. Not clear to me what these are. See, let's spot another one. No. I don't know. I'm not sure what those are. I mean, they're capacitors. Oh, are they? C610. Yeah, C610 must be 3300 picofarad. Look at this one down here. 3300 picofarad. Look at the way the symbol is so different. So there's something going on here for sure. They're up to something. They're up to no good. Okay, did we finish with the power supply? So coming out of here then is high voltage. There it says right there, 260, I think. And was it 150 here and a 50 here? And this one, oh, they didn't, oh, 25 here. Any more? Is there another one stuck here somewhere? Well, when we look at the radio, we can find it. Occasionally they draw, like in some schematics, they draw all the filter capacitors in the power supply area. In other schematics, they tend to litter them through the schematic. They can end up being way up here somewhere. But it doesn't look like in this one. Oh, maybe right here. What's this? Okay, so this is associated with the FM side of things. So the FM detectors, there's a couple different types. Boy, can I recognize what they are doing in here. This is another area where the engineers are just going to go to town doing their thing. So there's a number, like 2 or 3 standard types, 1 or 2 common types, and then they would fiddle them with a few extra parts here and there, especially these European designers. So I don't know if that is the guy. Oh, 2 microfarad, 2 microfarad. So this is the right size. So in most FM radios, there is a capacitor like this in the detector circuit, which really needs to be replaced if it's in any way bad. And I've commonly done FM radios, not commonly, but I look for this capacitor and change it, and it almost always has a significant benefit in the quality of the sound. You remember the sound in this radio? FM was terrible. It could be that guy right there. And I think I've hit the end of the road here looking at the schematic. Okay, so let's take a look at the radio and see if there's anything more now that comes to mind now that I've got some notion of the I've got some notion here. Oh, I'm up a little close with the camera. Okay, so what do we got? So we've got a whole bunch of slug-tuned coils all waxed up completely. And we've got a bunch of capacitors down in here, and they don't appear to be waxed, but that's probably because they just couldn't wax it. That's probably why they didn't wax them. 1, 2, 3, 4, 5, 6 of them there. 1, 2, 3, 4, 5, 6 here. Okay, here's the IFs here. One of them is AM and one is FM, and I don't think I could tell looking at them. You know, so there's more pages in the schematic. Maybe it's revealed. There may be a layout page. I put this piece of foam here up against this. I wonder what their concern was, that they would put a piece of spongy foam in like that. So these are these appear to be waxed. No one has poked through them, have they? They don't all look consistent. These two look waxed. These two look fiddled. Don't know. A little tiny capacitor could be that thing right there. That could be the FM capacitor right there. Could be. Look at them. Look at them down there. Look at that. Like, yay. So think about how they put this radio together. Yeah. Yeah, think about that. So a good number of capacitors are easy for me to get at. Maybe the repair process with this guy is just do the easy stuff first and see where that gets you. The easy stuff being the easiest obvious stuff. All these kinds of capacitors. Let's look underneath again. Just take this plug out here. Now, if I remember right, there was not a lot of parts under here. So I'm trying to look right up in here. You know, so they make these radios so they're fairly accessible like this. Oh my gosh, what has happened to that? Time for a close-up camera shot of this. Not quite sure what I saw there. Yeah, let's wheel the close-up camera. It's not really a close-up camera. It's a camera I can hold close. Figure out the difference there. Okay, holding close. Things don't look nearly as good when you get up close. So what did I spotted this thing. This thing, what is that? Oh, what has happened to that? Let me see if I can just get a little bit closer here. There. Well, whatever it is, it's not in good shape. So green usually means copper. There seems to be green down on the board all over the place too. It looks like the outline of a liquid spill. Almost. It really does look like a lot of liquid got on here, and then you're seeing the shoreline is left. It really looks like it there, doesn't it? Oh, what kind of liquid is there that can pour out of? I mean, what's got that much liquid in it? This thing? Well, nothing has liquid in it. Nothing has liquid in it. What? Well, you know. So the problem with it being green like that is that it's probably a coil, and it's been corroded to heck. I don't know what to make of it. It's an observation. Let's continue with the close-up here. Maybe there's more egregious stuff I can spot in this radio. More green than that thing. What is that? It's hooked up to one of the outputs or the inputs. I'm not going to worry too much about it. Ooh, what happened to that wire? Looks like a solder strike. Soldering iron strike. That's what it looks like. Also looks like a mouse chewing is what it looks like too. Maybe like the green wire. Maybe he chewed a bit and went bleh. European radio's no good. There, made in 1870. I don't think I'm going to see anything too exciting here. But you don't know. You don't know what there is to be seen until you go looking for it. Okay. Did I miss anything? So these are the filter capacitor connections. More green stuff. What is the green stuff? Okay. I don't know. Green stuff. Is there something they would apply? I don't think so. I've never seen anything quite like that. Let's see if we can find some more green. Like here's some green right here. Oh, look at that wire. Huh. Is that a piece of string tied around it? Piece of string tied around. I don't know if that's a piece of string. I don't know. Look at that. It's weird. You see the green main coil, and then down below is a finer wire coil. Looks like with some kind of braided winding. So the thing about these coils is, you know, these are not a dime a dozen. Oh, what is that black crap there? Looks like they probably dripped something onto it to hold it together, or keep those lead wires from unraveling. And you see how this one's come undone, and the one with the little black ball on it, it's popped off. So this coil is unpeeling now. It's unpeeling. It's not appealing. It's no longer appealing. And the same thing happening on the others. So there's the black tar to freeze the wires. I don't think it's important. It's just interesting how they do things. And some things had to be done in the main. There's one that's popped off. That's the same one. Different angle. You have to do things in the manufacture of the radio to build the radio that. That's the same thing everywhere. There's the guy in the foam. Tons and tons of light wires down here, just ready to be broken by somebody clumsy like me. Here's another one of those parts that looks like a, where'd it go? It looks like a fuse or a diode or a something. Okay. Now come along the filthy back here. Now is that one of those? That's a crummy capacitor. I'll get right in the center of the screen there. That will have to be changed out, and look where it is. Oh my gosh. How am I going to get at that one? There's one way down there. I'm not going to be able to get the camera in close enough to focus on it, but way down there. There's another one. Not just down there, way down there. So some of these you can kind of abandon them by cutting a lead and then replace them underneath the board if you can figure everything out. Because, you know, how am I going to get anything down in there to do anything? And last place to look, right around here. So this is the where the antenna comes in. Piece of junk. Well, that's not so bad. That capacitor's not so bad, I suppose. Look at the dust on it, though. Coils. Looks okay. That's the tuning capacitor. The outer plate is bent out slightly on both sides here. tuning is very smooth, by the way. It's very nice to turn. And this guy. Look at how far out that outside plate is bent. So that's not a mistake. That's a factory alignment operation. Now look at the geared wheel there with 2 sets of teeth on it. There should be a spring, we can see it. I think it's a spring clip sort of thing you can kind of see there in the camera on the left side. So that's an anti-backlash technique. That's why the tuning is so, there's like when I'm tuning it here, there's zero sensation of play in this. It's because of this double gear technique. Okay. You can clearly see how the plates have been bent. See, the splits in the plates allow a person to bend a section of the outer plate to affect different areas of the tuning, if you like. Different areas along the band. Okay, now let's just take a look at the FM situation. Oh, I'm looking up. There's a big hole. Hey, is there something missing here? How come this is open? What am I looking at? That's the AM. What? That's the bottom of the FM can. It's just a sealed can. Okay, no mystery there. Looking down at the FM can from the top. So you can see, again, there's a slug tune there, and it's waxed up. And you see that red thing hanging out? That's a little piece of rubber, like a rubber string, that's shoved, as I understand it, shoved down inside, kind of between the slug and the paper form. And that is just to give it more traction, I guess would be the word for it. Let's look at this one over here. Well, that's kind of curious. Why did they leave that stick sticking out there? Oh. Okay, I guess it's just a piece of dirt. There's the tuner number, 1972. Do you think it's 1972? This radio was made? 1972. Radio made with tubes. Don't know. I don't know if you can make this in 1972. Another piece of loose debris. Well, that's pretty much a close-up look at this guy. Maybe we need to look at the output. Transformer, I haven't looked down here yet too closely. What is that? So 150, no, 0.15 microfarad. So, and look at that. Now is that burned? Now this is clearly a resistor here. Pretty clear to me. Is that burned? I don't think so. No, I think that's a black mark, and that's a black. Ooh. Okay. A lot of these radios have a kind of fuse, sort of a resistor fuse kind of arrangement up here, but this one doesn't seem to have it. Odd looking, very odd looking things. I don't see them. There's the main fuse. And notice before, soldered in with wires as opposed to popped into the clip. And the far end. It's not, let's just make sure we look at everything. There's nothing to see over here, really. Just lots of numbers. Here's the magic eye. Ooh, that's quite a housing it's clipped in. up. I think that's a rubber band. I think that's a rubber band holding this thing together. And of course, rubber band's under tension. Tension supplies energy. Energy helps with chemistry. And there you are. So my guess is if I touch that band, if I go to take this tube out, it's probably the end for that band. The tube might go in loose in this holder. I don't know. This holder, wow. The tube, it looks like you could snap it in through this gap, but no way. If you made any attempt to do that, you break this holder, and you're in big trouble. See, it's clipped on here with a clip of some sort. It's quite a complicated little mechanical arrangement here. It clips down here. So this is not... Man, couldn't you come up with something a little less part-oriented here? Holy smokes, you gotta have a plastic piece here, a clip coming around, a clip coming around here. And what about this dial face? What about it? So these radios tend to have a lot of strings. Is there a string down below there? Sometimes they have. Yeah, there is. There's. You can't. Can you see it? The pointer, the far end of the pointer, it's out of focus, but it's actually between two nylon strings, which are under tension. They're attached at this end. Sorry, it's out of focus, but I think you can see it. And they're attached at that end. Usually these things are under spring tension. Wait a minute, they go down lower. They go down lower because, you know, there's an upper pointer and then there's a lower pointer. Where's the lower pointer? Where's the lower? We've lost the lower point. There it is. There's the lower pointer. So it's also got riders, nylon strings. These strings often break. They're held under tension with a spring quite often, and they break. And it can be confusing. Is it just what they were? It seems just fine in this radio, though. Good. I think it's all really good. Yeah. Okay. Oh, maybe not. There's just one more thing to look at here. Nice colored wires coming out of the output transformer. And there's the actual windings of the transformer exposed. Seems a little odd, doesn't it? Doesn't it seem odd that they would make this? So I think this piece of plastic here has shrunk. I think it's pulled up at the bottom here. Why would this one shrink and the other piece of it right there not shrink? Torn away. Maybe a piece was torn away somehow. Looks like it shrank at the top too. So I'm looking for evidence of heat. That's why I'm focused on this. Did that thing shrink? But there certainly isn't any indication that this thing has overheated or burned or anything like that. And then the big power transformer is completely in a can here. We can't see any of it at all. But good. Okay. Now, what to do about this radio? What to do about it? I think the same plan still holds perfectly true, and that's change out these capacitors that I can see and get at fairly easily. Do all the easy stuff, then run the radio and see if maybe the FM distortion has gone away, or anything else is. See if it's still working. Maybe. Make sure it's still working. After doing that, there's tuck down in here. Yikes. Well, that's going to be the project. Change those capacitors out. Boy, beyond that, tuning this radio, I don't know. Let's not go too far ahead. Get too much on the plate at once, you just don't feel like eating. That's what ends up happening. That's kind of the other way around, isn't it? Put more on your plate, feel more like eating. Good. That's it. That's it for today. That's as much as I can do right now. I'm gonna let this stuff percolate through my head, and I'm gonna go outside, play with my cats, and have another. It's another glorious day outside. Hotter yet today. A little bit of humidity coming, but wow, we're just having the most fantastic weather here. Great. So thanks a lot for watching this. I hope you found that interesting. And from here, we'll start messing this radio up. That's what I. That's what I imagine. See ya.